Our last and most important example of how to use quadratic equations to model things is using it to model projectile motion. So projectile motion just means anything where we are taking something and we are firing it up into the air and then letting it land on the ground. So in this one, a water balloon is fired at an inclination of 45 degrees to the horizontal from a dormitory window with a height of 26 feet and an initial velocity of 100 feet per second. Who would do such a thing? I don't know anybody who's ever done that. Okay, the height of the projectile is modeled by this equation right here, where t is time in seconds. So think of it this way. Here's our dorm and here's our window, and they fire the thing and it's going to go up in the air and then it's going to land on the ground here. Does that make sense? So where is the maximum height of this projectile? Well, remember, anything that is fired into the air will follow ideally a parabolic motion. It will be in the shape of a parabola, and we can see this is the shape of a parabola. It's got a squared in it, it's opening down because the a is negative, and so it's going to have a maximum height. It's going to have a maximum spot. What is it that we do when we want to find the highest, the biggest, the most of anything that we are maximizing, or the smallest of anything we are minimizing? We find the vertex. So let's take a minute and find that vertex. Remember, x equals negative b over 2a is how we find the vertex of any quadratic in quadratic form. So negative 71 over 2 times negative 16, that will be 71 over 32, which if we put that into our calculator is 2.21875 as a decimal. And it's not approximately, it is exactly that as a decimal. That is not rounded. How do we find the y value? Well, we're going to plug this h, and by the way, this isn't an x, it's a t, because that is what we have in the place of x, it's a t. We're going to take this time and plug it back into the original function, so we're going to find h of 71 over 32. Plugging that in, we get negative 16 times 71 over 32 squared plus 71 times 71 over 32 plus 26. And if we put that into our calculator and take our time, what we're going to get is 104.766, and that is a rounded number. So what is our vertex? The vertex is 2.219, comma, 104.766. That is our vertex. Now, every time you find a vertex in a word problem, you know it's not an x and a y, it's a something and a something else, right? So instead of x, we have the letter t. And instead of y, we have the letter h. And what did those things stand for in our problem? Take a minute, reread the problem. What did t stand for? What did h stand for? Well, t stood for time and h stood for height. Now that we know that, let's go back and read the question. How many seconds will it take for the water balloon to reach its maximum height? Is that a time question or a height question? It's a time question, and that is 2.219 seconds to reach its maximum height. The next question is, what was that maximum height? Find the maximum height. Well, if we look at our vertex, the vertex is the highest point, and 104.766, and if we look at our labels, that's in feet, is the highest height that the balloon gets to. Fantastic. Now, the last question that they can ask doesn't have anything to do with the highest. So let's read this next bit and let's sort of think about what it says. It says, how long will the water balloon be in the air? And I know it says set this up, but we are going to go ahead and take a minute to solve this. How long will the water balloon be in the air? So let's think about it. We fire the water balloon from a window and it's in the air and it's in the air and it's in the air until it does what? Until it hits the ground. Okay, what do we know about the ground? We know something very specific about the ground. How high is the ground? If you're on the ground, what is your height? 0. Okay, so what we want to kind of put together is the balloon is in the air until it is on the ground. And the height of the ground is 0. So what do we need to do to our equation? Negative 16t squared plus 71t plus 26 is h of t. Well, when we take this equation where are we going to put in that height of 0? Is a height of 0 a time or a height? It's a height. And remember, h of t is one big y. So we're going to plug the whole 0 in for h of t. So we get 0 equals negative 16t squared plus 71t plus 26. Now, is this a vertex? Is the ground at the highest point? No, it is not. It has nothing to do with the vertex. But this is a quadratic equation equal to 0. And remember, we had 3 ways to solve a quadratic equation, but really 2 that we use the most. Factoring. Can this factor? It cannot. It does not. Just trust me on this one. That mess does not factor. So if it doesn't factor, what are we left with? Quadratic formula. So t equals negative b, remember put everything that you plug in parentheses, plus or minus the square root of b squared minus 4 times negative 16 times 26 all over 2 times negative 16. Remember, we're going to start by putting this stuff under the square root into our calculator and very carefully calculating that. So 71 squared minus 4 times negative 16 times 26 is 6,705. So t equals negative 71 plus or minus the square root of 6,075 all over negative 32, because 16 times 2 is 32. This is actually 2 times. We have time equals negative 71 plus the square root of 6,075 over negative 32. And we have t equals negative 71 minus the square root of 6,075 over negative 32. Now, the problem with these answers is I have no idea how long that is. Is that 2 seconds? Or is it 200 seconds or 2,000 seconds? I have no idea how long that is. So we need to take a minute and put them into our calculator and let the calculator simplify them for us. Start with a fraction. We're going to do negative 71 plus the square root of 6,075, and we're going to put that over a negative 32. And we will get this looking thing, but hit that SD button and turn it into a decimal. So this is negative 0.217 seconds. And let's go ahead and put that second one into the equation. And remember our shortcut, you can always hit this back arrow. And all we have to do is delete the plus and make it a minus. And we have the second one. Again, it simplifies it for us, but we want the decimal. So that's 4.654. So our 2 possible answers to the question is how long is the balloon in the air is either negative 0.22 seconds or negative 4.654 seconds. Which one of those makes the most sense? Well, time can never be negative. So the water balloon is going to be in the air for 4.654 seconds.